Hey, good morning, guys. So we're changing up the plans just a little bit. We were going to do 9.8 on Tuesday, but we're going to split this apart for today, Wednesday, and tomorrow, Thursday. And then we'll do 9.9 on Friday. So next week, we'll see. We don't know yet if we're having school or not because we're going on a week-to-week basis. So I'm still thinking we're going to have our test next week either way, whether or not we have school or not. There will be more information about that later on. I'm still trying to figure things out for you guys. But today I think it's an easy way to get started for this e-learning. It's quite an easy lesson, actually. It throws together things we've talked about in the past. So this is 9.8, day one. The learning goal for today is we're going to be able to determine whether a function is linear, exponential, or quadratic. So quadratic's probably the freshest in our brains. That's what we've been talking about. Our quadratics have been the parabolas or the u's. Remember, there's symmetry there. Linear, right in the name it says line, right? So that's easy to remember. It's just one of our straight lines, right? We spent basically two whole chapters on that an entire month. So hopefully you guys remember lines, linear functions, they're straight lines. And then exponential, we talked about in chapter 7. I know your favorite chapter. Remember, they could represent exponential growth or exponential decay, and they look something like this or like this. So remember, we kind of talked about there was an asymptote that these lines would never cross, but that's not going to be entirely important to us. We're going to be able to tell if a function is linear, exponential, or quadratic based on their graphs and their equation, okay? So that's what we're trying to tackle today. Tomorrow will be another way. So let's go on. Give me 1 second. All right, so linear equations. Now, if you recall linear, we said this almost 1,000 times. Y equals mx plus b is the general form of that equation for lines. And so if you recall, there's different numbers. It could be 5x minus 7. It could be y equals 1/2 x plus 1. If m was 0, it could be like y equals 1 or y equals 1x. There's just a bunch of different equations. Now, one thing to notice that's really important is there are no exponents. Okay? So, if there's no exponents, that's generally an indicator that equation is going to be linear. So if there's no exponents in our equations, if you look here, no exponents, here no exponents, here no exponent, and there no exponents, then it's probably going to be linear. Okay? And now lines, that's graphically. So we look for, or not graphically, at the equation, we look for exponents. There isn't any. If you're looking at a graph, all it has to be is a straight line. So it can be anything as long as it's a straight line. There's no curves or anything. Give me 1 second, guys. You had an extra?
Oh, yeah, there's an HDMI one in the Strive plug. Use mine.
You sure?
Yeah, Strive has one. So.
All right.
All right.
Thank you. Thank you. All right, sorry about that. Santa Claus came. I got a present. So they just have to be straight lines. I know my blue line wasn't that straight, but that you guys get the picture. They're not parabolas, and there's not exponential growth or decay. It's just a straight line, okay? So if you're looking at a graph and it's a straight line, you know it's going to be linear, okay? And if you look at the equation and there's no exponents, you also know it's going to be linear. So you're going to see examples later on where we use this, but for right now, keep that stored in your brain. Now, I would recommend writing down notes. I know it seems silly, but really it is to help you guys, okay? We don't know. We could be back next week, just going about the same way. Then you remember final, open note, maybe, question mark, exclamation point. So it's important to just take notes just in case, and it helps us remind us of things, reviewing, so on and so forth. So please, at any time, feel free to pause this video, and get caught up by writing things down. Otherwise, I'm going to keep going. So exponential, this is chapter 7. And so exponential, you had a variable as an exponent. So if you look here, the general form is a times b to the x. You have x as an exponent. That's a variable as an exponent. Okay? If there's a variable as an exponent, it's going to be an exponential equation. So examples could be y equals 1 to the x, 2 to the x, I don't know, y equals 3 times 2 to the x, y equals 4 times 7 to the x. You could even add a 1 at the end or subtract anything. I could say minus 7, I could say plus 1/2. The only thing that matters is that x, okay? If there's a variable as an exponent, it's going to be exponential, okay? So if you're thinking about it as an equation, if there's an x in the exponent, it's going to be exponential, okay? Now let's graph this. Now our graphs were either exponential growth or exponential decay. So this kind of looks like exponential decay because it's going down over time. You could have one exponential growth going up. Some could go up quicker. Some could go up not as quick. It's just exponential growth. If we're looking at a graph, they're not straight lines, but they're also not our u's, our parabolas, right? Because quadratics, what we talked about last chapter and this chapter, are u's, our parabolas. Now these aren't u's. It almost looks like they could be half a u, but they're not because they keep going. So if you kind of look, it's like an arch, but then they start to level out, okay? So I think they have very distinct looks, so I think it's obvious which ones are exponential. I think you guys will agree. So finally, quadratics, the general form, y equals a x squared plus bx plus c. This is what we've been talking about all chapter, so we cannot forget this. So examples of quadratics. Well, before I get ahead of myself, if we're looking at the equation, we have a number times x plus c. So if you just had this, that kind of looks like a linear if you just look at that. But what tells us that it's a quadratic is the x squared, okay? If you have a variable, to the second power, you have a quadratic, okay? So you have to have that x squared piece there. You don't even necessarily need your bx or your c. As long as you have an x squared, it's technically a quadratic, okay? And these are our u's. So examples of equations, you could just have an x squared. You could have 7x squared, 3x squared minus x. You could have y equals 3x squared minus 2x plus 1. The bx and the c, those last two terms don't tell us that they're not quadratic. It just has to have an x to the second power, and that'll make it a quadratic, okay? So if we're looking at the the equation, if it's an x squared, it's a quadratic, okay? So all of these are quadratics because they got x squared pieces on them, okay? And then these all are in different shapes and sizes, but they're all going to basically look like parabolas or u's, okay? Some could be fatter, some could be skinnier, some could go open up, some could open down. Now, one thing we only briefly mentioned is that parabolas can't open to the left or right. That's a no-no. Because if you recall from way back when, the vertical line test determines if something's a function, if you recall. And this line could hit the function more than once if it's going up or down. So it's not a function, okay? So these parabolas are either opening up or down, okay? And so you know it's quadratic because it's a u or a parabola. you know exponential is an exponential either by x in the exponent, or because of the graph, you see it's exponential growth or decay. And then linear, there's no exponents at all. You just have an x and a value, and then the graph is just a straight line. So an example of our types of problems. So we want to determine what type of equation the following graphs represent. So I'm going to quick draw a couple of graphs. And we need to determine what type of graph they represent. It's either linear, exponential, or quadratic. So we have three options, okay? So if you want to pause the video and try to think about this yourself, go for it. But I'm going to go ahead and go. So first off, easy one, look at the middle. It's a straight line. So we know it has to be linear, right? Line is in the name linear. So it makes a line. Well, we know that these quadratics that we've been talking about make U's, right? So this graph is a quadratic. And last but not least, process of elimination could tell you it's exponential, but if you look, it represents exponential decay, right? It's not a straight line, it is not a U, so it's an exponential graph, okay? So that's part of your homework, that's half of it, and really I don't think that's too difficult, so I think you guys will enjoy today's assignment. It should be relatively short for you guys, okay? So let's go on. So now, another type of problem, the second half of what you're going to be doing, is we need to determine what types of equations the following represent. Okay, and so we're going to use the hints I told you about that I often wrote on the left side of the previous slides. So let's just go from left to right. So first off, what we should be thinking is exponents. On this first equation, do you see an exponent? I certainly do, right here, right? Now, if there's an exponent, there's two options. Either it's quadratic or it's exponential. Exponential has a variable in the exponent, which is not the case here, right? We have a number in the exponent. So if you have an x to the second power, remember that's quadratic. So this is going to be a quadratic. All right, let's go to this next one. Y equals 7x minus 1. Again, let's look at the exponents. Do we have any exponents? No. In fact, we know it's a line, but it also fits the form y equals mx plus b, right? M would be 7, b would be minus 1. So this is a linear function. And then, again, process of elimination, or we look, exponents, let's look. Our exponent is a variable. So hopefully you wrote down, if our variable is an exponent, then we know it's going to be exponential. Okay? So this is in essence all our homework is going to be today. Okay? And so last but not least, I challenge you guys to try this one first. This is a time sign. Not sure how that happened. So if you want to pause me and try to label these yourself, that's awesome. But I'm going to resume doing this. So again, we're asked to do the same thing. I look to this left side right here, and I look for exponents, which I don't see any, right? And if you look, this does fit the y equals mx plus b form. B, there's no b over here, right? So b would just be 0, m would be negative 1/2, but that's okay. There is no exponent, so it's going to be linear. Okay, well let's look at the middle one. You have an exponent, and it's this x, right? You have 4 times 60x power plus 1. Now don't be fooled by the plus 1. Maybe that kind of looks like linear, y equals mx plus b, but our variable is in our exponent. So if our variable is an exponent, like it is, we know it has to be exponential. Okay? And then last but not least, y equals 3x squared minus 1. Well, we do have an exponent, and it's a 2. We have x squared, right? And so if we have an x squared, we know that that's going to be a quadratic. All right. So I believe that's all I have for you guys as far as the lesson. It's short and sweet. I think we're going to start off this e-learning short and sweet, and let's see how this goes. So I'm going to post a worksheet in Google Classroom for you guys to complete, kind of like what we talked about. And you guys are going to have to complete it either on a separate piece of paper, or you can print it out if you have a printer. And then you're going to have to complete it, take a picture of the completed copy, and then post it in the assignment in Google Classroom. So this is going to be due tomorrow. I believe I'm going to set the time at noon tomorrow. So Thursday at noon it's due. That could change. I'm still trying to figure things out. I'll definitely let you guys know. And then make sure that you're filling out the Google form for daily attendance, because I have to mark if you're here or not. Okay? And so we're going to do that by a Google form. It'll be quick, 3-minute, like I'm here. I watched the video, or I haven't watched the video. I've done the homework, or I haven't done the homework, and maybe a spot for questions, okay? And so that's how I'll make sure you guys are here each day. So you'll have to fill that out every single day. So I'll post that every single day. Also, I don't think we'll need a Zoom conference for this. I think this is an easier lesson. If the time comes where I think a Zoom is necessary, I'll let you guys know how that'll work, okay? If we have lots of questions over this, we'll definitely Zoom. But try this worksheet, please. You can rewatch the video, slow it down, pause it, do what you need to do, and just be ready for tomorrow's lesson, because we'll use some of these ideas for tomorrow's lesson. All right? So with that, I'll see you guys tomorrow, and thank you for coming to my TED Talk.